CE amplifier. In this session, now we will discuss about practical setup of a transistor CE amplifier. So, why this is so called transistor CE amplifier is because this is the amplification device that is used in this circuit is a transistor, and it is connected in a common emitter mode. So, this is called as transistor CE amplifier, and it contains a BJT and other passive components like capacitor and resistors, and a source device called voltage device, and it is applied at collector terminal. And if we go through the circuit, then we can find the circuit which is a amplifier circuit, and this is connected to a and this is powered by a VCC voltage of 12 volts, and the biasing structure that is applied, that is used in this practical CE transistor amplifier is potential divider bias or voltage divider bias. Why we are using this voltage divider bias is because we know that this will gives a proper and stabilized amplification to the transistor or to the signal. This gives a stabilized operation, and its stability factor is very less. So, we are using potential divider bias technique to provide biasing to the transistor, and at the input is applying at base of the transistor, and the input is applied through a capacitor, that is Cin capacitor. Why we are using capacitor here? Because to stop the DC factor that is included in the AC signal. If the AC signal which is applying at the input, if it contains any DC factor, then it is eliminated by this capacitor Cin, and that is blocked by this capacitor, and the AC signal which is to be amplified is transferred to CE amplifier or transistor, CMOS transistor. And now we can see this RC and RE resistors. RC is a collector resistor and RE is a emitter resistor, we know this. And CC, that is a coupling capacitor or output capacitor. This is used because if we are connecting this to a load, then we are using this coupling capacitor. Why? Because if the DC of the DC voltage of the biasing setup of the amplifier circuit must not interfere with the load. So, to block the DC that is to be interfered from the amplifier circuit to the load, so to block that DC factor, we are using coupling capacitor and a bypass capacitor, that is CE. Why? Because we are using bypass capacitor, the RE value is very high. If you use very high resistance value RE, then the maximum voltage drop will be occurred at this RE, and very less amount of signal will be transferred to load, and this the more drop at the RE also disturbs the biasing of the circuit. So, to reduce these effects, we are using low reactance path to the AC signal, and for that cause we are using capacitor across the CE. The AC signal which is to be transferred will be transferred through the CE capacitor, and if there is any DC, that will be blocked by CE, and the biasing will not be disturbed because the voltage drop at the RE is constant, and the AC signal which is to be transferred will not disturb the RE, and RE will not disturb the AC signal. So, for that cause we are using CE capacitor.
As we know that capacitive reactance is 1 by 2 pi Fc. If it is AC signal, then the capacitor will provide low reactance path.
This is the CE amplifier, and we have already seen that R1 and R2 are the resistors which will provide biasing from the voltage source, which these are used to make this circuit as a voltage divider biasing circuit, and capacitor C1 will block the DC from the input. If we apply input from the from any source, input source, then if it has any DC in their output, it must not interfere with this amplifier circuit. So to stop that DC, we are using a capacitor here, and the capacitor CC is a coupling capacitor. We have already seen this, and the capacitor CE will provide a low reactance path to the AC signal that is amplified in this circuit. The CE will provide a low reactance path to the AC signal that is to be transferred to the load, and the the reactance of the CE must be XCE is less than or equal to XCE is less than or equal to RE by 10. RE by 10 is nothing but RE is the emitter resistance, and it must be less than or equal to emitter
1 by 10th part of
value. So this will provide low reactance to the AC signal, and that is to be transformed to the output. This is all about practical CE transistor amplifier, and we will see the different setups from the from this practical CE amplifier. Those are RC coupled, direct coupled, and transformer coupled with the and in all the cases we will use this practical setup